Hello everyone. In this video, we will talk about diodes and applications of diodes, and also we will perform some circuits in a multisim to demonstrate the applications of diode. So let's start. To begin with the diode is a bipolar junction device. As you can see, diode has two legs. First one is connected with the P part, it is called anode, and second one is connected with the N part, it is called cathode. So diode is a bipolar junction device. Diodes are generally manufactured by using semiconductor materials like silicon and germanium. When P part and N part is combined with each other, junction is created between the P part and N part. As you can see, this is a junction area, and also this is and also one region is created nearby the junction. It is called a depletion region. In the depletion region, the charge carriers are there. So when we apply the forward bi- when we do the forward biasing with diode, this depletion region or a junction become a very thin, and potential barrier will also decrease. When we apply reverse bias to the diode, this depletion region or barrier voltage will increase. So what is the forward bias and reverse bias? When we apply higher voltage to the anode and lower voltage to the cathode, it is called forward biasing. And when we apply lower voltage to the anode and higher voltage to the cathode, it is called reverse biasing. So now we will see some circuits in multisim. So let's open the multisim. So we will use silicon diode. So its code name is 1N4007. So this is a silicon diode. Also, we will take DC battery. So we will take DC battery and also resistor. Any circuit needs a ground to complete. So we will take ground. So let's connect the circuit. Now we will see that the potential barrier for silicon diode is a 0.7 volt. Now we will verify it. So we use one multimeter. We will connect it with respect to the resistors. Now we will run the circuit. This is a silicon diode, so the battery is providing 12 volt, and the drop of the diode is a 0.7 volt. So we should get here approximate 11.3 volt. As you can see, we are getting 11.339. So now we will see another application of diode. So this is a circuit which name is a battery backup system. So we made this circuit using normal silicon diodes. This circuit is will work as a battery backup system. So as you can see, this is the power source and this is our battery, which is stands for backup, right? So so the power source is right now is giving at 12 volts. Now we will see what is the output across this our system. We consider this load resistor as our system or as our complete usage. So we will see output is 11 point, it will approximate 12 volt. Now if in our area, if electricity cutoff will happen, then power source will be zero. Then battery will provide our usage voltage, right? So this circuit will work as a battery backup system. So now we will talk about the LED, is a light emitting diode. So LED is one type of special purpose diode. LED has the ability to generate different colors of light using required voltage. LEDs are manufactured by materials like gallium arsenide phosphide, and gallium phosphide, and some other materials. According to the materials and voltage, LED will able to generate different color of light. So LED has a two connection points. So first one is the anode and second one is cathode. LED works in a forward bias region. So now we will talk about practical application of Zener diode. So this is a circuit which is called waveform clipper. I made this circuit using two Zener diode, which is commonly used Zener diode 1N4738A. So I used function generator for giving input in different waveforms, and I connect also oscilloscope to see the output waveform. I connected our input voltage to the channel A and output voltage to the channel B, so we can compare output and input both. So this circuit will work for all three types of waveforms, which is for sinusoidal waveform, triangular waveform, and square waveform. So I designed this circuit as a we get output we get a half of input voltage in output. So I am applying 15 volt peak voltage and applying sinusoidal waveform. Now let's see the output. So this red sinusoidal wave is a input. So this is a 15-volt peak, as we can say. So now let's see the output. So our output is also nearly 7.5 volt. So by that we can say this will work for sinusoidal waveform. Now let's check for triangular waveform. Now we will apply triangular waveform which amplitude is 15 volt peak, and we will did same thing. We will do same thing. So as usual, this is our input, which is nearly 15 volt peak. Now we will see the output. So our output is nearly 7.5 volt. We can get a clear value by adjusting this pointer to the peak. So by that we can say this circuit is also works for triangular waveform. Now we will see for square waveform. So let's run the circuit. So generally in square waveform we used to measure peak to peak voltage, and then we will convert it into peak voltage. So here the peak to peak voltage is 13 volts. So our input is 15 volt peak, and our now let's see the output. Our output is a 15 volt peak to peak. It means our output is 7.5 volt peak. So by that we can say this waveform clipper will work for all three types of waveform, which is a sinusoidal waveform, triangular waveform, and square waveform. So that's all about the practical application of Zener diode. So now we will talk about Schottky diode. Schottky diode is also one type of special purpose diode. Schottky diode is manufactured by using N-type semiconductor material with metals like gold, chromium, tungsten. Schottky diode has the ability to work in a high power and with more efficiency. Also, it has the ability to perform faster switching action, so it has a less reverse recovery time. So reverse recovery time is a very important factor when we use this Schottky diode in a practical use. So let's see in a multi-sim. So first we will see that why normal diode is not able to perform this type of task which Schottky diode is able to do. So we will take one normal silicon diode and we will take AC power. Also we will take one resistor and we will take one ground to complete the circuit. Now let's connect the circuit. We want to see the output in form of graph, sinusoidal wave. So we will take one oscilloscope. We want to apply 10-volt VRMS and we want to apply frequency 100 Hz of frequency. So let's see the output. As you can see, the output is very clear and graph is also certain and accurate. Now we will increase frequency. Frequency is basically a duration which is performed in 1 second. So this is a 100 hertz frequency. It means 100 times of conversion into positive to negative and negative to positive will be performed. We will increase frequency to 1000 hertz. Now we will see the output. There is a, we can see that there is some amount of uncertainty is a graph. So this time duration, this small amount of this is we call time duration, or this time duration is called reverse recovery time, where diode requires the time to stay in its natural state. So this is a reverse recovery time. Now we will increase frequency to 10,000 hertz, and now we will see the output. We can see that there is a more amount of uncertainty is available in graph. So here reverse recovery time is a very high because the we increased the frequency. So because of that, diode is not able to do that amount of faster switching. So that we need to use Schottky diode. So we will use Schottky diode. In diode, we will go to the Schottky diode and we will use 10BQ015 Schottky diode. Now we will apply 1000 hertz of frequency to the Schottky diode, and let's see if diode is able to perform or diode is able to give us constant output or not. So as you can see, Schottky diode is providing us a very clear output. Now we will increase frequency. As we seen earlier, at 10,000 Hz, normal diode is not able to provide very clear output, but at 10,000 Hz, Schottky diode is providing us a very clear output with minimal amount of reverse recovery time. So because of that, Schottky diode is very useful in practical circuits. Every circuit manufacturer has used to one Schottky diode in his circuit to protect the circuit from voltage spike and also to perform circuit in a faster switching. So this is all about Schottky diode. So in this video, we seen about the diodes and its applications. First, we seen a diode, then we seen LED, and at last we seen a Schottky diode. So this is the practical applications of a diode. Thank you.